Hello, welcome to another podcast of Abhayam Dialogues. Today we have with us Dr. R. Balamurali Krishnan, who is Associate Professor at National University of Science and Technology in Muscat. Just to give a brief introduction about himself, he has done his bachelor's in civil engineering from Annamalai University, master's in structural engineering from Annamalai University, and PhD in structural engineering from Annamalai University. He has about 13 years of industry experience working in various construction projects in India and in Saudi Arabia. Since 2001, he is working at Annamalai University as assistant professor, and he moved to Muscat in 2013. And since then, he is working as associate professor at the National University of Science and Technology. So today he will be, or we will be rather, discussing a very important topic on understanding or a better understanding of structural design and the different construction materials from Dr. Balamurali Krishnan. So let us welcome him. Thank you very much, sir, for joining this podcast. So I leave the podium to you. You can start your presentation.
Thank you, sir, for your nice introductions. First of all, good morning to everyone present here. I would like to thank Mr. Shyam, Director, Abhayam Skill Training Academy, Bangalore, India, for inviting me to deliver this great guest lectures on the topic of a better understanding of structural design and materials. With your permission, I go to the PPT mode. Things are visible, sir?
Yes, yes.
Okay, I come to full mode. Okay, thank you. So the topic is a better understanding of structural design and materials. This is a present topic. This is a current topic also. We should understand the better understanding. That is more important. Not only understanding, it's a better understanding of structural design and material. We start from dedication. See, look at this diagram. The first one is simply supported beam. The second one is cantilever beam. The people, those who invented for simply supported beam, bottom is tension zone, top is compression zone. When come to cantilever beam, top is tension, bottom is compression. This is a real dedication. Those who are inverted these conditions, simply supported and cantilever beam. Then who is an engineer? So according to former USA President Herbert Hoover, who was an engineer before he became a politician, said the great liability of the engineer compared to the men of other professions is that his work are out in the open where all can see them. His act step by step or in hard substances. He cannot bury his mistake in the grave like the doctors. He cannot argue them into the thin air or blame the judge like the lawyers. He cannot, like the architect, cover his figure and with the trees and vines. He cannot, like the politician, screen his shortcoming by blaming his opponents and hope the people will forget. The engineer simply cannot deny he did it. If his work is do not work, he is damned. This is the major problem for civil engineer. We cannot hide anything. Everything is open. Everybody can come and see his work. That is witnessing his work also. So start from concrete. So concrete is nearly what are the base material for concrete is a cement. Cement is a binding material. The age of the cement is nearly 150 years. Earlier the grade is 33 grade cement, 43, 53. Now people are using PPC. PPC means Portland Bazalonic cement, fly ash based and silica film based in 43 grade. So what is meaning of 33, 43 and 53? 33 is a grade of cement. The grade of cement we cannot reflect directly to the cement in terms of mortar. In terms of mortar in the sense, The grade is 1:3 mix ratio, the cement mortar. The cube size is 75 mm by 75 mm by 75 mm. At the end of 28 days curing, it should be 33 Newton per millimeter square. The grade of cement in terms of mortar strength. We keep in mind the grade of cement in terms of mortar strength. We can say 33, 43, 53. Earlier, India, we were using 53 grade cement, but some curing issues are coming because of early strength. 53 means 53 Newton per millimeter square, the compressive strength of cement in terms of mortar. Okay, that's why right now we are mainly focusing on durability aspect, not strength point of view. Strength and durability, two things are very important. During the serviceable time, you should not give any crack or expansion or a temperature shrinkage or thermal variations. You should be avoid during its serviceability condition. That's why our Indian scenario, people are worried about durability aspect. That's why right now people are using PPC, either fly ash based or silica fume based. So what is fly ash? Fly ash is mixed with the cement particle. The fly ash is more finer than cement, nearly 4 times more finer than cement. That's why easily filling into the gap of cement molecules, each and every molecules. So finally, we are getting the blended cement. We can very well avoid temperature variation, shrinkage variations. But one small drawback is that the PPC cement. Normally, the age of the at the end of 28 days curing, we are getting for full strength, 100% strength. So the variation is gradual variation. At the end of 28 days, there will be no difference. But initially, for example, 7 days curing, when compared to 43 grade ordinary Portland cement with the PPC cement, the variation is slight variation is there. At the end of 28 days, there will be no difference. If 43 means 43 Newton per millimeter square, if 53 means 53 Newton per millimeter square. Why it is called ordinary Portland cement? Portland is in the name in England. Where we are starting from the cement. They only found the cement. So later on, it is called Portland cement from the name itself, the place name. Okay, why it is called ordinary Portland cement? Ordinary Portland cement without any ingredients in the cement is a plain cement. Is a plain cement. Now the cements are changed. They are blended cement with the help of fly ash and silica fume. Now we fix the grade also, the 43 grade, because of the temperature. Because of the temperature, we limited to 43 grade. Some special case people are required for 53 grade or OPC cement. Based on the order, they will produce from the factory. Okay. Next, the grade of concrete. The grade of concrete we have minimum is M20 grade of concrete for RCC. Normally we call it as normal strength M20 to M55. High strength concrete M60 to M100. Now people are using above M100. Recently they found M20 concrete also. M is a mix. 20 is the characteristic compressive strength of concrete after 28 days curing. So the minimum grade as per IS 456 for RCC M20, PCC M15, pre-stressed concrete, pre-tension, we have two types, pre-tension and post-tension. I am talking about minimum grade, M40 and M30. Then come to rebar. What is the meaning of rebar? Rebar is nothing but a reinforcement bar. Reinforcement bar, or we can say steel. The reinforcement bar worldwide accepted. We come to Gulf country or other countries, the people are calling rebar only, not they are saying for steel. Okay. So earlier we are using for mild steel. You know what is the meaning of mild steel? This is a plain bar without any ribs. The yield strength is not more than 250 Newton per millimeter square. That is a maximum range of mild steel. Then they can go for tar steel. Tar steel normally drawn from mild steel. Tar steel normally drawn from, that is word is very important. If you look at the stress strain curve for mild steel and tar steel, mild steel we have definite yield point is there. The tar steel there is no definite yield point. It's moving to end, beginning to end. So why it is happening? That means the tar steel is drawn from mild steel. That's why there is no definite yield point for tar steel. For tar steel, what are the yield stress? As per code provisions, minimum is 415 Newton per millimeter square. We are using for CTD bar, cold twisted deformed bar, then TMT bar, thermomechanically treated bars, QST bar, quenching self-tempering bars. So among the three, the TMT bar is very familiar. What is TMT bar? Thermomechanically treated. Constant heat and constant cooling. Heating and cooling is parallelly they are doing. So to increase the corrosion resistance. Corrosion, even though the rebar is get corroded, but the resistance will be more for TMT bar. Thermomechanically treated. Now people are using for FE 500 is very familiar in India. Nowadays 550D also available. 550D for ductile. Suppose now we are going for high grade steel, 415 to 500, 500 to 550. They are losing its ductility. So they are balancing the ductility also in 550 Newton per millimeter square yield strength steel. The recent development is FRP bars, fiber reinforced polymer bar. If we talk about fiber reinforced polymer, we have two type of bodies there. Glass fiber is very famous, and carbon fiber, and one more fiber also is there, aramid fiber, that is very costly. That's why people are trying glass and carbon fiber. And one more bar is there. If your construction is very closer to the coastal area or offshore structure, we go with the coated bars. Coated bar means is a fusion bonded epoxy coated rebar. Is just like electroplating technique. Electroplating technique, a constant temperature, the bar is moving into the paint booth. The paint is already electrostatically charged paint. They stick onto the surface. It is a flexible epoxy system. Flexible epoxy system. Epoxy paint is the superior one. So we have enamel paint, polyester resin, then epoxy. Epoxy is a superior one. Is a two combination, base and hardener. Base and hardener. If you mix together, the polymerization process will take place. So epoxy is very rigid and flexible also. If you apply on the bar, what will happen? If you bend the bar, the paint also bend accordingly. This is the advantage of the paint. Otherwise, what will happen if you bend the bar, the coated bar, if you bend, the paint will be peel off. That's why they're using for flexible epoxy system. If you bend the bar, the paint also bend accordingly. So normally the thickness is 250 to 500 microns. You know what is meaning of microns? 1 divided by 1000. 1 divided by 1000, that is for microns. Next, FRP bar, what we discussed early. So this is for glass fiber. Now the recent development, we using carbon fiber also. Then hybrid fiber also using, mixing of glass and carbon fiber together. Hybrid bars are available. FRP bars are available. So only thing, shear is the problem. The remaining thing, it is fantastically working. We did a lot of experimental work in our college, in our university. The problem is shear. Shear is because of modulus of elasticity. Modulus of elasticity is very poor compared to steel. That's why shear is the major problem for FRP rebar. For bending is okay, ductile is okay, everything is fine. Only for shear. Shear concern is you will take doubly careful when you're using the FRP bar. Once you use the FRP bar, there will be no corrosion. So your building will be, the corrosion is a major culprit for building. The corrosion is nothing but of is a cancer process in concrete. It's a concrete cancer. Corrosion is a concrete cancer, so similar to human cancer. Once the cancer is started, it will propagate to everywhere. This is the major problem for concrete. If your rod is not corroded, you can ensure for your building is 100 years or 80 years. So because of the corrosion only, the building lifespan will be reducing. Okay, next we come to coefficient of thermal expansion. This word is very important for concrete. We are using for RCC. RCC for two material. One is concrete, another one is steel. It is a composite material. As you know, what is the meaning of composite? Two or more element of different material act together and carries the load. This is for composite. So in the concrete, we get two materials. One is concrete, another one is steel. So act together and carries the load. So normally we are talking to our student. The concrete and steel is made for each other. Made for each other. How? Made for each other normally for lovers and husband and wife. We are telling made for each other. But here, the concrete and steel is made for each other. The only one reason we cannot replace steel right now. That is the major issues going on. Nearly more than we are using the concrete RCC more than nearly 150 years, almost 150 years. So still we are not able to replace the steel. In the big person or rich person, instead of steel, they cannot go for a golden rebar or copper rebar or chrome rebar, etc., etc. What is the reason behind that? Only thing, coefficient of thermal expansion. The coefficient of thermal expansion for steel and concrete is almost similar. That is the only reason the concrete and steel act together monolithically. That's what we call is a mat. It is mat for each other. Mat for each other. If the high temperature, like our Gulf countries, say about Muscat, the temperature is more than 50, 55 plus. The hot temperature, steel and concrete is not coming separately. Or if you fire the concrete up to 300 degrees centigrade, the concrete and steel not come out separately. So still 300 degrees centigrade, the steel and concrete act together monolithically. The reason behind that, coefficient of thermal expansion. The coefficient of thermal expansion, steel and concrete, almost similar. See, 12 into 10 to the power of minus 6 per degree centigrade. So this thing is very, very important. It is the only reason still people not able to replace steel in the concrete. So many we are trying for FRP, not 100% successful. And come to admixtures. What is the meaning of admixtures? Other than cementitious material in the concrete. Cementitious material means we have cement, fine aggregate, coarse aggregate, water. These are the cementitious material. Other than cementitious material adding into the concrete for many purposes. Nowadays, the admixtures role is unbelievable. Normally, generally, two types of admixtures available in the market. One is for chemical admixtures, another one is for mineral admixtures. Chemical admixtures always mixing into the concrete, normally in the water. But mineral admixtures are always mixing into the cement. This is very, very important. Mineral admixtures with the cement, chemical admixtures with the concrete. So we have air entraining agent, accelerators, retarders, plasticizers, waterproofers. You know what is meaning of accelerators? To reduce the setting time of concrete. What is the setting time of concrete? Normally, initial setting time not less than 30 minutes, final setting time not more than 600 minutes. This is for general concrete. In our concrete, normally the setting time 4 to 5 hours. Final setting time 4 to 5, 6 hours maximum. Okay, but initial setting time not less than 30 minutes. It should be more than 30 minutes. Otherwise, so many operations involved. You have to placing, leveling, vibrating, and finishing. So many operations. We need some sufficient time. Otherwise, we are not able to reach the surface, good surface with the entrapped air. So because of that, we are adding some admixtures. Accelerators, we want to reduce the setting time. Retarders, normally for batching plant, people are using retarders. So normally after batching plant means from the batching plant to site, it's not more than 1.5 hours. This is a maximum limit. Within 1.5 hours, we can pour the concrete. So how to delay the setting time with the help of retarders? Then plasticizer normally using for reduce the water content. The water is the main culprit for concrete. If more water, less strength. Less water, more strength. Okay, vice versa. If you less water means what will happen? How to balance the workability with the help of plasticizers. Then waterproofers. So many waterproofers available in the market. Is a damp proof course. So many things are available. We are adding into the concrete with preparation of concrete mix. Mineral admixture, bazolons, fly ash. Fly ash means coal burning ash. India, most of the places are depending on coal. We produce electricity through coal. So coal burning ash. The waste material is after burning of coal, the waste is called fly ash. This is very finer than cement. Other thing is silicon. It is a silicon industry. Rice husk. You know what is meaning of rice husk ash also we are using. Metoclin. GGBS. GGBS is ground granulated blast furnace slag. It is a waste material from steel industry. Again, mixing with the cement. Mineral admixtures normally mix with cement. Chemical admixtures normally mix with the concrete. Maybe they mix with the water, okay, etc. etc. Then plasticizers, just now we discussed. They're very interesting. Plasticizers normally, the role of plasticizers will reduce the water content. Reduce the water content means the workability will be lost. How to balance the workability with the help of plasticizers? So normal range is 5 to 10%, and mid range is 6 to 15%. High range is up to 40%. We reduce the water content. The role is very important. If you mix the super plasticizer into the concrete, what will happen? This super plasticizer, each and every molecule of the concrete is make them separate. Just they form a small balloon. See, look at these things. Small balloon and each and every particles. So what will happen? Because of this balloon, each and every particle will depart from each other. So the friction free. The friction free means we can easily mix the concrete. During the hardening time, setting time, each and every molecules or bulb molecules around the particle is ruptured. Finally, there will be no superplasticizer. This is the concept of superplasticizer mixing into the concrete. So many companies they're producing the superplasticizer. For India, Fast Chemical is there, Sika, Prodrite, LK, Hurricane. Many companies are available nowadays. They're producing the superplasticizer. The range is very important. But before adding the superplasticizer into the concrete, you should know the quantity. Even in the manufacturer, not telling the exact quantity. The range only they're giving 50 to 250 ml for 100 kg of cement. 50 to 250 ml for 100 kg of the cement. If you look at any manufacturer brand like Fasta Chemical Superplasticizer, they're mentioning like this. Again, you go to make it for 50 half, then you can go with a lot of trial mix. Here I am trying with the Fasta Chemicals here. Trial mix, based on the trial mix only, we come to conclude either 2% is optimum or 3% is optimum. Normally, it ranges 2 to 3%. 2 to 3%. After optimize the superplasticizer only, we can fix the quantity to the concrete. One thing happened in India, one of my friend is adding little more also without our knowledge. So normally people not discuss with anything. Anything happened wrongly, only people are called. So next morning, what happened? They adding the superplasticizer previous day little more also. What happened? Without any base study, he's simply adding. His thought is, client thought is, by adding more, the concrete will be more strength. This is a general idea for common people or laymen. So what will happen? Next day concrete, just pushing the finger is going inside, slightly inside. Immediately called him around morning 6 o'clock. When something was happened in my construction, my concrete is next day. Nearly they stopped concrete previous day, maybe 4 o'clock they end the concrete, they finish the concrete. Nearly more than 12 hours. So just what will happen? Within 6 hours, it will set, must be set. So if you put the finger, what will happen? Slightly going inside. Immediately asking, you are adding any admixtures? He said, yes, adding admixtures. Each and every batching, adding little more also. How much you are adding? He adding nearly 400 ml per bag. The maximum is 250 only. Maximum. The maximum also it is not correct. We go with the optimization. Then only it around 3%. 3% means 125 ml to 200 ml. But this fellow add 400 ml per bag per batching. So what will happen? Delayed setting time. Delayed setting time also major drawback in the concrete. It loses strength. Suppose we are fixed for M20 grade concrete. For delayed setting time, the concrete will not achieve for 20 Newton per millimeter square. M20 means 20 Newton per millimeter square at the end of 28 days curing. So I didn't tell anything to that fellow. Otherwise, he may be worried. I asked them to cover the gunny bags, a small wetting of the gunny bags. Immediate next after 24 hours, it will be set. I told like that. So finally, after 24 hours, it is set. How much? Nearly 36 hours is taking for setting the concrete because of excess superplasticizer. You should control the superplasticizer adding into the concrete. That is very, very important. Don't simply purchasing from the market and don't add your concrete without any idea or without any base study. Then composites, polymer-based composites. Nowadays, lot of required materials available in the market. So it all based on polymer modified concrete, polymer impregnated concrete. These things are available in the market. Latex modified concrete. Latex is a rubberized material. It is an artificial rubber, not a natural rubber. Latex modified concrete. Then FRP, we discussed it earlier. GFRP, CFRP, aramid, and cement-based concrete, furrow cement, silicon, slurry infiltrated, fibrous concrete, slurry infiltrated, matte concrete. These things are used for normally this part, silicon and silicon, they are using for bomb blast structure. High tensile capacity, the tensile capacity is very high. I tried in my beam retrofitting system also. I will tell you a little later. Then plate-based composites, steel plate, stainless steel plate also you're bonding on the surface of the concrete, either beam or slab, whatever it be, in column also. Okay, this is for external reinforcement. They are using for CFRP. carbon fiber wrapping, steel plate. This is for retrofitting or enhancement. Retrofitting is nothing but of enhancement. Rehabilitation means to retain its original load carrying capacity of the structure. To retain, go back. Okay. Then retrofitting means enhancement. Suppose you want to increase the capacity of the column or beam, whatever it be, so you can go with this kind of retrofitting using steel, GFRP, CFRP, etc., etc. So this is for glass fiber mat wrapping. So this is the bonding into the bottom surface of the beam. That means tension phase of the beam. This column around four side. There is normally 30 to 40% will increase the load carrying capacity. We are using this kind of retrofitting system. Normally 30 to 40% increase the capacity. This is carbon fiber wrapping. This is also the retrofitting. See, beam and column is perfect condition without any distrust in the concrete. Why they go for these things? They want to they applying the retrofitting technology. Retrofitting means enhancement, the further improvement. See, this is a carbon fiber wrapping in the column. This is beam column joint, four beams meeting at the column. They're using for carbon fiber wrapping. Normally for seismic, the beam column joint is very important, mainly for the joint only fail during earthquake or heavy wind blowing, the joint would be failed. So normally compression tension is continuously acting. Finally, it will be detached. So this is a vulnerable zone for seismic prone areas. This is ferro cement. The ferro cement is very famous. Not now, quite more than 50 to 70 years. Ferro cement is very famous. Installation is very easy without any much difficulties. I think you might have seen in the drops of the portico, everything they're using the ferro cement, chicken mesh or weld mesh with the high performance mortar. The mortar is 1:2 or 1:3. Only mortar. The mortar will penetrate into the gap of the meshes. So finally, it is a reinforced mortar. Finally, it is a reinforced mortar. If the high temperature, like Gulf countries, the people are using mesh at the outer surface, then go with the plastering. They increase the tensile property of the mortar. So finally, to avoid the micro cracks, macro cracks in the surface of the wall, the ferro cement is the easiest way, is the cheapest method of repair. It acts as a repair material, and also it acts as a drops, panels, precast panels. They in small water tank, we can go with the ferro cement water tank. Even boats also available in India, small boats with the help of ferro cement. Normally, we are using the skin reinforcement to maintain the shape. This is the skin reinforcement, normally smaller diameter, 8 mm or something. Over that, you put the chicken mesh or weld mesh or single layer or two layers. It depends. Okay, the ferro cement is a very cheapest material, easily available in the market. Chicken mesh is available in the roll. So this is a strengthening of using the ferro cement technology. So one construction I did in long back in India. This is a low cost construction. This is for segmental ferro cement roofing. Segmental. This is for all precast, then joined together, then filling with the gap, and finally you put the plastic tiles. So this is very, very cheap and very cost effective also. So this is a lightweight partition. If you go to high-rise building, the major problem is a dead weight. How to reduce the dead weight of the building? Only thing we cannot reduce for column and beam size. That is as per the design. Only thing you can reduce the filler material. Filler means partition, outside wall, inside wall, whatever it be, we can reduce. So normally this lightweight material, using lightweight material, we get lightweight partition. Lightweight material means pumais, sintered fly ash, many things are available in the market. We are using lightweight material, we get lightweight partition. The density is around 450, and one more ALC panels are available, autoclaved lightweight concrete. The density is around 650 kg per meter cube. Our concrete is nearly 2400 to 2500 kg per meter cube. Within 300 or 400 kg per meter cube, we can go with the lightweight partitions. So finally, the dead weight will be reduced. For high-rise building, dead weight is a major concern. Your foundation also reduced. So finally, you are achieving for economical construction. So high performance fiber reinforced cementitious composites. Just this material I tried for beam retrofitting. So first I cast the laminate. Then this is the beam. This is a rectangular beam. For my convenient, I invert the beam. This is a tension phase of the beam. Just I go with the sandblasting. Sandblasting means to make the surfaces roughening. After that, I using the epoxy resin. This is a mixing of epoxy resin. Epoxy resin normally two material base and hardener. In the some filler is required. Fine sand or fine particles we can mix together. That is a filler. All three material base, hardener, and a filler are mixed together. They go to bonding on the surface of the tension phase. This is the final product. So it will increase the flexural capacity of the beam nearly 1.8 times. So this is also possible.
So this is put outside the beam or inside?
Outside the beam, sir. The open sector only. For our convenient, we will invert the beam. Just invert the beam.
So how the testing is done? Inverted or normal?
No. The testing is this is a testing methodology. So this is a support condition. We apply the 2-point loading here. Then we will reach up to ultimate stage, ultimate load.
But how will the bonding be there with the?
So that is a major issue, sir. If your bonding is good, there will be no issue for it. Act as a composite material. I told earlier, two or more element of different material act together and carries the load. Here, the two material is there. One is for beam, another one is for laminate. The two things is bonding with the epoxy resin. The epoxy resin, flexible epoxy system, till up to load spectrum, there will be any bond failure. Till end, we are achieving the compositeness. Once compositeness is lose the compositeness, nothing will happen. We are not able to achieve the target. So the resin is very, very important to achieve the compositeness. So in our case, up to ultimate load, there will be no delamination or debonding. That's why the things are very success. Now people are using all over the world, they're using the epoxy resin. Only drawback is fire resistance. It's not that much fire resistance. That is the only problem for epoxy resin. Other than that, it is fantastic material.
Instead of tensile reinforcement, can the laminate be put inside and then tested?
This is for repair work, sir. Retrofitting.
Retrofitting. Okay.
Retrofitting, or we can say rehabilitation. Distressed condition, we can do like this.
But can it be done for a normal beam as well? Can we replace the reinforcement?
Normal beam, we can do anything, sir. That's not issue. We can increase the reinforcement or put the bottom. Anything we can do. Only for existing structure, how to do retrofitting and rehabilitation. That is the main thing. Okay. During construction, anything is possible. Inside also possible. During construction is fine. We are focusing on existing structure. Okay, sir. Thank you. See, the another important thing, composite deck slab. You see, now the construction is steel column with the composite deck slab. If you go to any building, they are providing for main beam and the secondary beam. What is the main beam? Main beam is support to support, column to column. Secondary beam, the secondary beam is beam to beam. Secondary beam is beam to beam. So over that you have to place the deck profile sheet, and we connect the shear connectors. I will show the next diagram. Shear connectors, then you place the concrete. The reinforcement is almost negligible. It's a nominal reinforcement only we are providing. Over that, we place the concrete. See, the one of the construction in Tamil Nadu, Trichy, is my friend. Actually, this is a normal practice. He is doing his own way. During the construction, what will happen? The sheet will be sagging. He stopped the construction activities. Immediately he called me. Normally, when you provide the sheet, two type of construction is there. One is for proper construction, another one is for unproper construction. Proper construction means a regular conventional method. We give the props during concreting. After hardening, we remove the props. Another one is unproper, without any support is required. No props, no jacks, nothing is required. So the two-way. So during this case, particular case, see, I think you might have seen the sagging condition of the profile sheet. Okay, then they called me, we gave the solution. See, this is a composite deck slab, top view. Okay, so this is the main beam and secondary beam also there. I am showing the main beam. Over the main beam, we place the deck profile sheet. This sheet is called cold form sheet. You know what is hot rolling process, cold rolling process? Based on the cold rolling process, we can achieve this sheet with the corrugation. Then you provide the shear connectors. Shear connectors are drilling into the main beam. This is projected. This portion is projected. After drilling, this is projected. It is called shear connectors, or we can say shear stud. Why they are providing shear connectors? Means this is a sheet, the concreting. So what will happen? The sheet and concrete, we achieve the compositeness with the help of shear connectors. With the help of shear connectors. See, look at this sheet. This is a corrugated sheet. Then you place the reinforcement and pour the concrete. So this shear connectors will achieve the compositeness between sheet and concrete. Okay, this is called shear stud or shear connectors. This is nowadays all the construction is they're going steel column with the composite deck slab. Composite deck slab. So what is the advantage of deck slab? Very fast. No centering is required. No centering, nothing is required. No need to wait for anything. Immediately you can raise the column and go to next floor. So since the construction is unproper construction, that is the advantage. Unproper construction at the ground floor, we can do your connecting works. We can arrange the shops or something. We can start all the cupboard work, other things, everything we can do parallelly. No need to wait for concreting after 28 days, giving nothing. Nothing is required. Just parallelly you can do all the work at a time. These very speedy constructions. This is for composite deck slab. Everywhere this is very famous. A shopping mall, all the things made up of steel column with the composite deck slab. Right. Now we come to RCC design and detailing. Sir, anything is boring, you tell me, sir.
No.
Can I continue?
Yes.
Okay. Then RCC design and detailing. See, look at the beam. This is a T-beam. T-beam means including thickness of slab. That is called the beam and slab cast monolithically. The beam and slab cast monolithically. That is why it is called T-beam. Intermediate panels are T-beam. Exterior panels are called L-beam. There is no projection of flange on both sides. The flange is nothing but of your slab. There is no separate flange for any beam. The slab is act as a flange. The slab is act as a flange. So normally, the width of the beam, for example, this is for 300 or 230 mm. The number of reinforcement is, say, 5 numbers for 20 mm diameter. 5 numbers for 20 mm diameter. How to place the reinforcement? 5 numbers in single row, it is not possible because sufficient gap is required. Otherwise, the concrete is not able to penetrate into the concrete, penetrate into the rebar. In between rebar, minimum is 25 mm. Minimum is 25 mm or highest rebar used. Suppose the rebar is 30 mm diameter, means the gap is 30 mm. Normally 30 mm is required between the rebar. So how to place the rebar? I am placing like this. I am placing like this. So which one is correct? If you are placing like this, what will happen? Unnecessary pressure will develop in between the rebar. If you are placing like this, there will be no pressure. They are acting monolithically. Same way, what we provide at the bottom, similar to top, with the help of spacer bar. The spacer bar diameter is not less than 25 mm. Okay, this is the things. So this is correct. This is wrong. You understand? This is a placing the reinforcement for 2 layers. The spacer bar diameter is not less than 25 mm. Another interesting story. This is for tread raiser staircase. What will happen? Tread raiser staircase. So they provide the reinforcement at top zone. This is a compression zone. This is a tension zone. 2 layer of reinforcement is there. Everything is fine. They thought everything is fine. So they place the concrete. After 28 days, they remove the shuttering. What will happen? This is a collapse. Once they remove the shuttering, sudden collapse without any delay, further delay. After 28 days, after hardening, what is the reason behind that? So there is no interaction of compression reinforcement and tension reinforcement. We should interact. Otherwise, this type of cracks are coming, or this side are not crack, collapse are coming, not cracks. So compression reinforcement, tension reinforcement should interact. That is more important. See, top reinforcement, bottom reinforcement, you should interact. It is in the form of rings. This is the main reinforcement. This is also form of ring. This is the way we are practicing in the field. So this is a straight staircase. Normally we are adopting, we are using in the house construction, straight stair. This is a single flight, landing, like that. So every junction should be stress concentration is more. So If you are providing same tension reinforcement, keep it till end, it will be failed. The tension reinforcement at the junction, it goes to compression reinforcement. Compression reinforcement, here the top compression reinforcement come to tension reinforcement. It should interact in the junction. See, normally people are calling it is a scissor reinforcement. Scissor reinforcement. Look at this diagram, you can understand clearly. Mainly for staircase, at the junction, it should be scissor reinforcement. Tension should be compression, compression should be tension. It should be interact each other. The interaction is very important. See, look at interaction should be more important. Right. See, this is a diagram. This is a wrong, incorrect one. This is a correct one. Okay. The bottom reinforcement goes top. The top reinforcement goes down. Okay. There's some flat construction. The beams are like that. So the beam subjected to torsion. Normally, any construction or any beam, we have generally two stress resultant. One is for bending moment and shear force. Some case we have three stresses resultant: bending moment, shear force, and twisting moment. So this beam design is here twisting moment. Torsion is developed. Accordingly, you have to design the beam. So this is very familiar. All the bridge construction, bottom deck is steel, over that composite construction, deck slab. This is for RCC. The bottom beam is steel structure. Very speedy construction. So everywhere, all the here Gulf countries, in abroad, USA, everywhere, people are using for steel structure. Steel structure in the sense the pier and everything, the beam, pier, everything made up of concrete. This beam, peer-to-peer connection, this is for steel structure. Over that, deck slab construction is a concrete. The reinforcement position is very important. I will show the diagram, you can understand easily. Any column or beam, minimum diameter should be 12 mm. If you're using any reinforcement in the column or reinforcement in the beam, should not less than 12 mm diameter. That is more important. And stirrups also very important. Normally we called stirrups or ties when the column is subjected to shear. Shear means seismic force or wind force. That means horizontal force, or we can say it is a lateral force. The column is subjected to lateral force. The column is subjected to shear. In normal case, only for vertical load, dead load and light load, there will be no shear. In this case, it is called ties. The ties normally providing two-legged ties or four-legged ties. This is for two-legged. It all numbers. See, as per Indian code and British code, one tie should be connect all the reinforcement. And the same cross section we will to provide another ties. Same cross section, that is more important. So 2 plus 2, four-legged ties or four-legged stirrups, or some we can say either four-legged ties or four-legged stirrups. This is more important. I will show some diagram you can understand clearly. So this is for one-side footing. The one-side footing we are providing additional U-bar. The U-bar is required at the one-side footing. This is for the plan. U-bar is required. Eccentric footing. Otherwise, the column will be overturning. This is for cantilever. This is for sunshade. The sunshade normally the reinforcement we can make it like this. Otherwise, what will happen? The proper anchorage is required. This is called development length. You can bend the bar or take it at least 25 to 50% at the bottom. 25 to 50% at the bottom. This is for cantilever beam. This is column. How the cantilever beams are anchored. This is for additional reinforcement. Here, once the cantilever beam is there, this junction is subjected to huge shear. We provide some additional stirrups also required at the junction, beam column joint. See, look at this. This is beam column joint. Additional stirrups are required. It is very difficult to fastening at the site. So, anyway, you want to manage these things. Otherwise, what will happen? The failure will takes place at the junction because of the shear, mainly in the cantilever structure. This is called development length. This is for overlapping, lap length. This is formula for lap length. LD equal to pi into sigma is into 4 into tau BD. Normally in general construction, we are taking 50 diameter. 50 diameter. It is in tension, some variation is there. It is in compression is there. Suppose it is welding, the lap length will be less. In general, it should be 50 diameter. And one more beam is there. Beam is subjected to torsion. We are providing side face reinforcement. The side face reinforcement, the beam is subjected to torsion, 450 and above. Normal beam, 750 and above. The torsion beam, 450 and above. The depth of the beam is 450. The normal beam, 750 and above. We provide side face reinforcement. This is more important. There is 0.1% of web area. Okay, both sides you can provide. And the beam is subjected to torsion. When the beam is not subjected to torsion, in normal beam, the depth is more than 750 and more than 750, you can provide side face reinforcement. This okay? Right. Right. This is a very interesting thing. This is a cantilever beam. This is a prop. After construction, after laying the concrete, after 20 days curing, you can remove the prop. You can remove the prop from right to left or left to right. This is normally the confusing for all the people, side people, even right to left or left to right. And after removing also, some people, I think you might have seen in the site, they're giving one prop at the free end. So what will happen? These things we discussed in this photo. Understand? This is a cantilever beam. This is a column. The tension reinforcement at top. There is no compression reinforcement. In compression is zero. There is no need of any compression reinforcement because it is cantilever. We only dominating for tension only. Tension at top. Everything is perfect. We place the concrete. We waiting for curing. After 28 days, we place the props. Remove the props either this side or that side. Normally, we remove the prop from free end to supported end. And moreover, you should not give any prop support at the free end after construction, after hardening of the concrete. See, this is a wrong practice. What will happen? This beam acts as a proper cantilever. If you look at the bending moment diagram, you can understand clearly. See, this is a cantilever, maximum bending moment at shear force at support only, at the free end, only for deflection, maximum deflection at free end. See, this is a maximum bending moment. So at the support only, at the free end, zero is fine. Now, if it is providing one support like this, suppose you are leaving one support at the free end after reviewing the formwork, what will happen? See, this beam now it acts as a proper cantilever. Up to some distance, it is sagging, then hogging. Sagging is positive and hogging. In our case, there is no reinforcement at the bottom. Am I correct? There is no reinforcement at the bottom. So if sagging means we need reinforcement at the bottom, what will happen? So you understand the consequence. So don't give, if it is cantilever, you can treat it as a cantilever. If it is proper cantilever, you can treat as a proper cantilever. Don't give cantilever to proper cantilever. So some people are doing for portico, it is a cantilever. Later on, they converted, they raise the room at the first floor. They give the support at the free end. What will happen? The beam is acted as a proper cantilever. A lot of cracks are appearing in the wall. In many cases I attended in my area.
So this means that the engineers who are in charge at site should be technically sound, fundamentally strong to understand how the different structures are behaving.
Exactly.
So that they can inform the laborers. So this is a big challenge for engineers.
Yes.
Moreover, engineers where they interact with the laborers who doesn't know all these things.
Yes.
And you have to be technically and fundamentally strong to tell them this is what happens when you do such kind of nonsense things.
Exactly. So normally the house owners, any problem coming, only they approaching the engineer. Most of they construct one building and they thought they are reaching the just like an engineer. They act as an engineer. They construct 2 or 3 buildings. Their behavior, everything as an engineer.
The chief engineers.
Chief engineers, exactly. So they simply dictate to the labor, they finish the work. Then later on, immediately 3 months, sir, this one building in my place, near even my hometown only. After 3 months, within 3 months, so many issues are came. The entire wall, the outside wall is fully cracked. Unbelievable. The crack you can see outside also. That much wide crack. So these all things are happening quite common in our area. Not only in India also. See, the proper cantilever, this is a way of cracking. The lateral, so this crack is um, reaching to the wall also, over the beam. Right. The another thing, this is a one floor. This is a portico. This is the inside building. Now this is a formwork. I think you might understand. I somewhat manage with the AutoCAD drawing. Assume these are all the formwork. This is for sheeting. This is the jacks. Just assume here also there. After hardening, after 28 days curing, we want to remove the formwork. Which one is first? Either this side, inside, or outside. Some people, normal tendency of people, they are removing this side also.
Yeah.
The portico also. What will happen? Already the load is not transferred to the wall to the beam. It is all the load transferred to the jacks. You are centering and shuttering only. So what will happen? Chances are there the portico may be overturned without any counterweight. First, you have to remove this support
One, yeah.
inside first. Then automatically all the load transferred to the beam. So is a fully restrained without any movement, and then you can go to front portico. So there will be no further overturning or anything. Otherwise, definitely you are seeing the major consequence. This is for normally for grade beam, we are using for top and bottom in the clay soil. And this is a little deeper. I just skipped there. We get two type of theories there. One is for concrete theory, one is for steel beam theory. I don't go in deep. So this is a little complicated. Right. They come to arches. Arches, our tradition one, or all the heritage building, old building, palace, everything, they made up of arches. In the opening, mainly for opening, or door side. Okay, they provided the arches. Even our old construction also. 100 years, 150 years old building also made up of arches. Why people are using the arches in old construction? There is no RCC those days. Only for stone construction or brick or etc. etc. Either stone structure or brick structure. The brick is small bricks joined with the lime mortar. So they're using for arch concept. What is the concept of arch? That is, they understand those days, 1000 years, 500 years, they understand the concept of arches. See, what is the concept of arches? Each and every cross section, the bending moment equal to 0. See, this is an interesting thing. Each and every cross section, the bending moment equal to 0. What is the nature of, what is the tendency of arch? Only thing, try to flatten. If you apply the load over the arch, try to flatten. Only thing, the two edges is fully restrained, there will be no problem. This is the idea of the arch. So those days, the kingdom period, or in all the old heritage structure, even some bridges in old bridges also is made up of arches. This is the idea. This is a concept. The kingdom. So each and every cross section, the bending moment equal to 0. That's why still people are believing arches. See, this is one of the construction I did in India. This is one college building. This is the entry of the college building. They want to. This is arch type construction. Over that, the ornamental architectural point of view, one architecture sent the drawing for design. I did the design for this one. Is in Tanjore actually. This college in Tanjore in Tamil Nadu. Okay. So what the concept of arch I told you. So the reinforcement is very interesting. All the four sides we provide the reinforcement. That's all. The reinforcement must be all the four sides. This is an arch. All the four sides. It should be properly anchored into the column. Otherwise, arch, the tendency is try to flatten, to avoid the flattening of arch. The edge should be restrained, fully restrained. So there will be no flatten. The reinforcement is always four sides. Always four sides. Okay, this is another interesting story. Actually, based on our failure only, we formulate these things. It is not available in any textbook. This kind of, this is, compound wall construction. You try to understand, this is a compound wall. This is a pile. Normally 8 to 9 feet, you will put on pile. Not too much depth, around 7 feet or 8 feet. Okay. What will happen in all the outskirts of city? Normally the soil is almost clay soil. Clay soil is a bulging nature. What will happen if you construct the compound wall with the grade beam, straight grade beam, or conventional grade beam? What will happen? Due to it's a freestanding structure, there is no load on the top. It's a freestanding. So big construction, we are achieving 100% without, it's a crack-free structure. We did many precaution measures, but we are not able to achieve any without crack. We are not construct a compound wall. This is many compound walls are cracked. So finally, why it is cracked? So we, based on our experience, we came to understand the clay soil is bulging in the rainy season due to weight of compound sulfide. It is bulging. If bulging means the two pile is moving towards the downward, in between the soil is moving, bulging soil is moves upward. It will overturn your beam in outward direction because of bulging of clay soil. If it is horizontal beam, what will happen? It pushing the beam towards the top, pushing the beam towards the top. So the over the beam, your wall is there, the wall will be cracked. More wide at top, small, less wide at bottom because of bulging. So finally we decided this beam, we make as a small curved beam. Small curved beam. What will happen? There will be no crack at all. This is based on the experience only, you came to understand. Mainly for freestanding structure, especially for compound wall. So this grade beam, you know what is meaning of grade beam? It is the rest over your existing soil. So you make it slightly curved. Not this much. For understanding only, I am showing like this. It's slight curve. Say about 3 inch or 2 inch. We go to curve the beam. So we finally we completely eliminate the cracks. So mainly the clay soil. If you use soil condition is good, sandy soil, sandy bed, it is not required. It's only for clay soil. Mainly for the most of the construction in the outskirts, they are using for cultivated land only. They convert it to construction purpose. They are all the cultivated land. They make a market plant. They sell it to the people. So this is very interesting thing. The one of the construction I involved maximum part. Myself and my PhD camp both are involved in these things. This is Velangani temple, Christian Velangani temple at near Nagapattinam. It is in Tamil Nadu. So what will happen? They want to construct very big prayer hall. Very big. Don't see the religion point of view. Just you see the structural point of view. See very big prayer hall. The capacity is 10,000 plus. Minimum 50,000 people can accommodate at a time. So they want a column-free structure because they, Christian activities, prayer and other things are there. So they want to construct column-free structure. See, this is a column-free structure, 120 feet column-free. This is outside 2020. Total 140 feet. 140 feet. Sorry. 140 feet. You understand the structure? 140 feet. Inside a very big hall. Very big, just auditorium. So this side to that side, 140 feet. Okay, this is an arch type construction. We discussed the arch, each and every cross section bending mode is 0. Everything is fine. Finally, what happened in the arch? What is the tendency of the arch? Try to flatten. Arch is because of the load, because of the roof load and other things. It tried to flatten. The end should be restrained. The end of the arch. Its end should be restrained. So normally, how to restrain? With the help of the beam below the ground level. I think you might understand fairly. So what will happen? The arch, I told you, it tried to flatten. So how to arrest the movement of the arch? The arch is the slight movement is there because of the load, because of the flattening. So what will happen? The beam is subjected to tension. The beam is subjected to tension. Initially, we tried for RCC beam. The designer, not before construction, everything we analyzed. So what will happen? The beam is pulling. In the RCC beam, not possible. Then you go with the post-tension beam. Post-tension beam, we can post-tension beam stressed and anchored. This is pulling, that anchoring, both will be compensated or both will be nullified. The pulling force and compression, both force will be nullified. This is for PT beams, post-tension beams. Then PT slab everywhere is common. PT slab means post-tension slab. Normally flat slab. When you go to any building, any apartment building, huge buildings, office complex, IT corridor, everywhere in Bangalore, Tamil Nadu, wherever you go. So the construction is flat slab. What is the meaning of flat slab? Flat slab is nothing but a beamless slab. The beamless slab, we can go for RCC slab. RCC slab, it won't restriction. We can go up to 6 meter or 7 meter. That is a restriction. But people want column free structure, wide area, 10 meter without any column. So this is the only option. PT with the post tension. PT with the post tension. This is for post tension PT duct. This is for conventional reinforcement. It's a nominal reinforcement along with the PT. This is the end arrangement. This is the anchorage zone. This is called strands, small wire twisted together. Okay, it is a factory mat. This is for anchorage unit. This is a locking arrangement, male and female cone. After stressing, they lock it. Okay, we're not going in the next lecture. If required, we will go with the pre-stressed concrete alone, separate. Okay, the another thing, this is important thing. This is the main beam. The main beam, another beam is crossing. That is called secondary beam. Main beam and secondary beam. These additional reinforcements are required because the impact of the secondary beam will be more. You give two numbers of 12 mm diameter, you put it in this shape. Over that, you can place the secondary beam before concreting. Okay, this impact will be reduced. The load will be distributed to the beam because of this shape. This is called additional reinforcement. There is no design at all. Even mainly for floating column. You know floating column? Floating column means the column is starting from the beam, not at the ground, not at the earth. There is no foundation at all. That is called floating column. The floating column also not resting over the beam directly. We're providing this kind of reinforcement. Okay. This is a small
For a floating column, what should be the minimum depth of the beam?
Pardon, sir?
For the floating column to start, what should be the minimum depth of the beam?
That is very important, sir. Actually, any floating column we can consider as a point load over the beam. Accordingly, you can design. So normally the point load action is more. Like the floating column, all the load coming to the beam only.
Yeah.
Entire load is a point load. So accordingly, based on the minimum 2 feet depth, minimum 2 feet depth is required, minimum. But anyhow, we want to consider the point load action. Based on the point load action only, you can design the beam perfectly. Otherwise, the beam will be failed. Most of the
it should be designed as a deep beam or as just a regular beam.
The basically is a PT beam, sir. PT beam is more efficient compared to RC beam. Post tension beam is required. And nowadays, the IT corridors only they're using for floating column. They're using for the beam is made up of not only RCC, PT, post tension. That's why we minimize the depth. If you're using for RC beam, what will happen? The depth of the beam is very huge. Sometimes it may be 1.5 meter also.
Yes.
That's why they can want to reduce the beam depth with the help of PT. PT, you understand, the depth will be very much reduced. Mainly for the problem is the beam is subjected to point load. Point load in the sense of floating column.
When I was working in the industry, we were constructing one shopping mall.
Okay, sir.
And it was a 5-floor shopping mall, and from the 3rd floor onwards, there was a column. There was a ring beam.
Okay.
And from the ring beam, there were like 4 columns which was going on top.
Okay.
Like a aesthetic feature, and then there was another ring beam on top.
Okay.
And the height of the column was same as height of the 3 floors, around 12 to 15 meters.
So definitely that case is the beam should be designed as a D beam.
So that's what that beam, that 3rd floor beam was almost 1.6 meters depth.
Yes. Very critical, sir. Actually, normally we're asking what is the biggest shallow beam and deep beam. Shallow beam only one neutral axis. Deep beam more than one neutral axis.
Yeah.
Next slide I will discuss. This is for ring beam is there. Any water tank ring beam is there. The ring beam breadth will be more coming to depth of the beam. That is a major concept. Mainly for ring beam. B equal to D. D will be less. D will be more. Lateral thrust will be more. That's why all the ring beam designers B equal to D, D equal to B. So this wall is designed as a D beam. Wall is designed as a DP. See DP, mainly for side wall of water tank, basement wall can be treated as a DP. Okay. So people are asking, what is the DP concept? So more than one neutral axis. The analysis is a little bit complicated. Even one neutral axis above compression zone, tension zone, one neutral axis only for shallow beam. Here, more than one neutral axis, maybe two neutral axis coming for DP. Based on that, you can analyze the beam and followed by design. This is the D beam concept. I told you in the previous slide, confinement of column. So if you providing for two-legged stirrups, the voids will be more. You understand? Four-legged stirrups, the voids will be less. So the column is more confined. It depends on your stirrups. So the role of stirrups, it is 135-degree bend. The projection is around 10 diameter. Inner core of the concrete. Any lateral force acting on the column, there will be opening of stirrups. There will be opening of stirrups. It is well intact. Mainly for the column in the earthquake prone areas, these case you take doubly careful. Normally, when the lateral load is acting on the column, the first point of load transfer is stirrups. Once the stirrups legs are open, the vertical bars are bulging. To avoid the bulging of the bars, you have to provide proper stirrups, also proper legs. It is 135-degree with respect to horizontal, and also the projection of the stirrups or projection of the leg is like a scorpio leg, 10 times diameter. It is properly merged into the inner core of the concrete. You can easily understand the confinement effect. Two-legged stirrups, the gap will be more. Four-legged stirrups, the voids will be less. So now you easily understand pictorial representation. You can understand the confinement effect of the column. So the stirrups role is very, very important, and leg also more important. What is this? The transverse reinforcement, just we discussed it. This is for curtailment of bars. Normally, any reinforcement, this is the end. The beam is not continuous. It is 0.1 L1. Here, this is a continuous beam. That side, it is the curtailment is 0.15 L1. The point of contraflexure top 0.25, 0.25. Okay, from the face. So normally for fixed beam, the point of contraflexure is 0.2. What is the point of contraflexure? Bending moment is 0, or bending moment changes its side. Okay, so this is for 0.2. 2 is coming for fixed beam. 0.05 is allowance for only 0.25. Curtailment of bar. Okay, curtailment of bar means we got to curtail as per our bending moment. As per our bending moment. So minimum each corner one bar is required. Each corner one bar is required. See, look at the support, one bar only coming at each corner. Before that, we have to curtail. Similarly, at the top, this is for negative reinforcement. You can curtail up to this point. What about this point? It's not a blank. We are providing for minimum 2 bars, each one bar at each corner. Then we provide the stirrups. So suppose we support, we have 5 bars are there. So 3 bars are curtailed. 2 bars only going support to support. So this is a saving of bar. Or otherwise, you can unnecessarily you are giving the bar. There will be no savings. So any beam, the curtailment of bar is very, 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 very important. You should learn how to curtail the bars based on your bending moment. Based on your bending moment. Okay. This is for hinged column. This is very famous olden days. Nowadays, people are stopped to avoid the hinged column. Hinged column means at the junction, the grade beam and column, there will be no movement at all. That is the advantage. Once it's a hinged column, the movement is here 0 means automatically the column will be very thin, slender. Even in the old heritage house also you can find the wooden column, with the small boon is there. Then they can put it in over the stone bed. In architectural drawing, I think you might have seen one column, wooden column, and now small thing. That is a hinged location. That is a hinged location. Knowingly or unknowingly, people are doing in long back, 1,000 years back, 500 years back.
Especially if you go to big temples, you will see the doors on the hinge.
The wood mainly for the Keralite temple, sir. Just curve is there, small portion is there. After that, the resting over the stone bed. So if you want any opening in the slab, the junction, the corner should be restrained to give additional reinforcement. Otherwise, the crack will propagate at the corner. at the junction. This is an opening in the slab. Next, we come to retaining wall. If any retaining wall construction, you give the deep holes. Deep holes means other side earth fill. During the heavy rainy season, you can let out the water from the hole. Otherwise, what will happen? The weep hole is weeping. Just you don't understand what the meaning of weeping. Just
Crying.
crying. Exactly, it is crying. This is a weeping. So if it's not weeping, what will happen? Hydrostatic earth pressure will be more because of water is there during a heavy rainy season. The wall may be overturned. So the weep hole is very important for retaining wall construction. This is one of the retaining wall designed along that. So we provide the weep hole. The weep hole sometimes is clogging. That's why you provide for some brick bats and other things. We can provide this side nearly 2 feet. After that, they filling the soil to avoid the clogging of weep hole. And one more thing, retaining wall, every 25 meters, we provide the expansion joint. You know, the expansion joint, if you're giving the straight, what will happen? The soil will be escaped. To avoid the escape of the soil, we can bend like this. This is called expansion joint for retaining wall, not straight. So the soil will not escape because of the shape. Then rebar grouting. This is for a cathodic protection is very important for corrosion. Cathodic protection. Our Burj Khalifa building also, we are using normal reinforcement only. There is no special reinforcement, but they are providing for cathodic protection. Impressed current technology with the help of sacrificial anode. There will be no further corrosion. Always in active mode. It is in active mode. There will be no possibility of another systems entering into the rebar. Mainly for cathodic protection, mainly applying for the Gulf countries, all the oil exploration from the sea only. So they're carrying the oil through the pipeline. Normally they have to protect outside with a good painting, epoxy resin painting or something. How to protect inside? With the help of cathodic protections, they got to protect inside also to avoid the corrosion. The cathodic protection is very famous for all the building, high-rise building. This is called impressed current technology. Always 50 voltage passing through the rebar. So it is always in active mode without break. So there is no possibility of another current flow in the system. The corrosion is a potential flow, current flow. The corroded part will try to corrode uncorroded part with the help of dissolved oxygen. With the help of dissolved oxygen is required. Moisture is required. So moisture is there in the concrete because of increase of moisture. Dissolved oxygen also there. Oxygen current flow. Is act as anode. Another one is cathode. Uncorroded part act as anode. Corroded part act as cathode. Potential flow, it will corrode to other part also, good part also. That's why we are telling the corrosion is a cancer process, human cancer similar to concrete cancer. So we are going with cathodic protections. There will be no possibility of corrosion. But current flow always should be there. This is nowadays all the chemicals are using for repairing of rebar and spalling of concrete, etc., etc. Here the rebar grouting is there. The rebar grouting is very famous. You want to extend the beam with the help of rebar. How to bond the rebar with the finished beam? We make the hole. We provide the lock set. Lock set is nothing but of epoxy resin. Epoxy resin is filling in the hole. Then you fix the rebar. Is properly bonding into the gap. There will be further pulling out. So this is a way they have to extend the beam or slab, whatever it be. This is called rebar grouting. The rebar grouting nowadays is very common everywhere. So one thing keep in mind, expansion joint is, when we look at any drawing, first you will see the expansion joint locations. Normally as per code provisions, up to 45 meters, we give more than one expansion joint. On every turning of the building, expansion joint is required. Even adjacent story height varies, we give the expansion. One story is lower level, another story is higher level, the expansion joint is required. So this is an expansion joint in slab area. This is a material, the plastic material, rubberized material, flexible one. Normally for expansion joint, if you topmost floor, what will happen? There's two slabs are coming. With the provide the expansion joint, the water leakage will come. To avoid the water leakage, we provide the water stopper. water stopper during casting of the concrete with the expansion joint with the water stopper. I think how many of you try to understand these things? It's difficult to understand. This is the expansion joint with the water stopper. So normally in the expansion joint, water leakage is coming in the down floor. Immediate. Normally the expansion joint in between the floor, no issue. Topmost floor at the 50th floor or 20th floor, the water leakage we cannot arrest. So at the topmost floor, the expansion joint location, we provide water stopper, also the expansion joint. So it will the water stopper, you can arrest the leakage of water. Okay, this is the way we are practiced after long struggle. This is our experience only. We came to understand. Okay, the topmost floor we have to provide water stopper. This is the expansion joint, 1 inch gap normally 1 inch to 2 inch, maximum 50 mm. It depends on the size of the structure. See, this is a huge building where we give the expansion joint. Otherwise, what will happen? Concrete will be expanded. The expansion crack we cannot rectify. We cannot rectify whatever be the material. Any chemical material, phospha chemicals, whatever be the chemicals, we are not able to arrest unless otherwise we can provide the expansion joint. Okay, expansion joint means column is same. Sorry, column is different. Foundation is same. In between 1 inch gap. See, two columns are the big drawing. So two columns are nearby with the 1 inch gap. The foundation is below ground. Because foundation is below ground, there will be no expansion. Now, because below ground level, it is on cool temperature. Open structure only, mainly for concrete in the open area, we try to expand during the summer time. So expansion joint is very, very important for huge structure. If you go to any building, you can find the expansion joint. Normally, the expansion joint is close to with the what is it called? Stainless steel plate. One plate is screwed. One side is slotted screw. They fix it. Suppose the building is slightly expand means the slotted screw is allowing. This is the way we are practicing.
Like earthquake dampeners.
Exactly. We are allowing the movement. Both sides screw means very difficult. Otherwise, the sheet will be damaged. If the building is expand sheet, that's why one side is screw, one side is slotted screw. This is a recent trend in constructions. This is augmented reality, virtual reality, drones in construction, building information modeling in construction, 3D printing in constructions. So in future, these things are dominating in the field. No doubt at all.
It's already started. It already started.
Already started. Exactly started. In future, the 3D printing may be dominating. No doubt at all. So within few days, we finish the construction. No need to wait for 2 months, 3 months, 6 months. It's not required. Moreover, we ensure our quality also. So case study is required. I can stop it up to this level, sir.
That's fine. Go ahead.
Go ahead. Okay. So finally, come to one case study. Actually, this is a very interesting thing. This is actual building. This is a medical college building in Pondicherry. I don't want to tell the name of the college. If I'm telling the name, you might be understand. It is not fair. So what will happen? First, we tell the story of the college. This is a medical college building, still functioning near Pondicherry, in Tamil Nadu. But this is in Pondicherry, the border of Tamil Nadu. So what will happen? One fine morning, the building is nearly G plus 3 floors or 4 floors. 3 floors, I think so. Three floors. G plus 3. All the beams in the building, exactly middle of the beam is cracked, vertical crack. The building is old building, 10 years old building, 10 to 15 years old building, sorry. 15 years old building. Those days, now 15 plus 13 years. 30 years. I am telling for this story maybe 2012. That time it is 15 years old building. All the beams are vertical crack. In the middle of the beam, just to try to understand, middle of the beam. It's a medical college building. All the students, those days before NEET period, I think so. So all the students are afraid sitting, digging there at the bottom of the beam. Everybody is looking. The cracks are visible also. So the management is worried. Otherwise, we are not able to stop the entire college block. This is for college block building. Say they called us. when I was working in Annamalai University, they called us. So myself, my head of the department is visited the building. So we are looking everywhere. First, normally we going for walkover survey. So the building have some minor cracks, something is there. I just visited some cracks in the column, some the diagonal cracks are in the joints, mainly for windows opening. These are the things observed in the college. This is anatomy area. I saw the body also. Some students are doing something in the body. This is anatomy building. So very interesting. This some cracks in the beam also. Some joints are cracking. This see the condition of the college. It's a medical college building. Even the students also, they're giving those days maybe 50 lakhs or 60 lakhs for management quota. This time and after NEET, things are changing. They are deducting every year 15 lakhs or 20 lakhs. It depends on the standard of the college. See, this rebar is visible. This is a crack. This is a crack. Almost all the building is a crack like this only. Middle crack. See, look at the crack. Look at the crack. You understand? This is a huge building. G+3 or G+4, I not remember. So all the beams at the middle are slightly away from the midspan. Middle, not technically, it is a midspan or little away from the midspan. Even myself and my guide is Dr. Anthony Jaisagar. He is from IIT Madras. He is a very knowledgeable person. So we are looking the building everywhere, doing the walkover survey. We are not able to understand why the cracks are coming. We call some people to remove the concrete also, cover concrete also. This is we only remove this cover concrete. It is visible. Okay. I expose the rebar. The rebar is condition is good. Yeah, and the depth of the beam also good based on the span condition. There will be no much corrosion. The rings also good. The stirrups also 8 stirrups. Everything is fine. Closer spacing. Concrete is good. Is fairly. Our naked eye you can understand by during the walkover survey. See, really we are struggled. So we are going here and there. We are not suspecting for concrete also. Concrete also good. So finally we decided to bring all the equipment, non-destructive equipment. Rebound hammer, other thing is UPV, ultrasonic pulse velocity. I come to this slide. First I will show this testing. This is a field investigation. This is I put the rebound hammer test. This is one of our stock number. We are conducting a rebound hammer test. This is ultrasonic pulse velocity. We pass pulse from one side, other side we got a received. This is a pulse generator. Another one is a receiver. See this many points we are taken both side away from the reinforcement. UPV, ultrasonic pulse velocity, column, everywhere we are taking. So finally the concrete is good. Finally the concrete is good. There will be no issue for concrete. Rebar also not much corroded. Depth of the beam is okay. So we are literally confused. Finally, I think this happened in another day. First day they visit, they are not telling anything about the building. Second time is after 1 week gap. With the help of NDT equipment, we tested the building. From the test itself, we came to understand there will be no much difficulties, no much problem in the building. Then why the crack is coming? All of a sudden, after 10 years or 10 to 15 years, why the crack is coming? See, so suddenly we walking over the corridor of the building. We try to understand these things. Walking over the corridor of the building, we resting the foot on the tile. What will happen? The tile is crushed away. The tiles are heaping. The tiles are heaping. Just rest on our foot on the tile. The tile is crushed. See, this is a crushed area. I only crushed this tile. I asked this maintenance engineer in that college, in that university. No, sir, this is our regular maintenance. See, tile is a regular maintenance, he is telling. Every 6 months or 1 year, remove the tile and refix it. It is coming within 1 year, sir. Again, remove and refix. So, if we remove the tile here also, then look at the structure. Structure is fine, no issue at all. So, this portion only triggered us. This is only because of expansion. The root cause is very important. Any doctor, we are telling who is the best doctor. He's talking good. He's smiling face. He's a charming face. good face, nothing. He understands your disease or root cause of the disease, can suggest the medicine accordingly. The root cause is very important. Otherwise, we are not able to cure the disease. This is one of the disease, structural disease. This is only because of expansion joint. It's a huge building. Actually, in the plan, expansion joint is available, but the time of construction, they completely violate the expansion. Without expansion, construct the building. Then they give the solutions. That is a big story. I'm not telling. I have to compile these things. These are the investigation. NDT method. NDT is a non-destructive testing method. Rebound hammer, ultrasonic pulse velocity. We use all the equipment. This is UPV. See, this is for indirect method. This is called direct method. Direct method means this is a direct. Here, pulse generator is acquired in another side. Direct method. This is indirect method. The slab also is checked. So because we are totally confused, finally suggest the building. This portion, the expansion joint is required. How to give expansion joint in the existing building also we suggested. That is a big story. I'm not telling right now. Okay, right. Just to understand any building, the expansion is very important. Okay, finally coming to the last slide. See, look at the tree with the branch. The branch is nearly for 40 feet. Normally, the structure, it is a column, it is a cantilever beam. For designing a 40 feet cantilever, is it possible? Anything is possible, nothing is impossible. But the 40 feet cantilever is very difficult. That much column size is required, foundation is required, counterweight is required. Many things are required for making the concrete structure, RC buildings for 40 feet cantilever. But this tree, without anything, simply the branches are 40 feet standing without any problem. What is the reason behind that? It's the energy. Energy is more important. This is a live tree. It's not a dead tree. It's a live. The energy is more important. In our structure, there is no energy. There is no energy. It's a dead structure, dead weight. Dead weight, this much structure is required for designing a 40 feet cantilever. But this tree branch, 40 feet cantilever, without anything. Simply, even small diameter, they will project this much without any damage. So live is more important. Normally, people are telling dead weight is more. The body, the person who died in the normal weight is 65, 70. In the dead weight is more than 80. Because you say dead is weight will be more. Live, dead will be less. Because of energy.
You have forgotten one thing. At the end of the cantilever, there is a point load. In the tree, at the end of the cantilever, there is a point load also.
No, sir. Nothing point load, sir. This here going like this, sir.
No, that's why the branch is going up, no? So it is a point load.
Point load not touching on the floor, sir.
Not touching on the floor.
Not touching. It's heavy. So energy is more important. Anything. So in the life also, we have to more energy to achieve the target.
Yeah.
Okay, sir. Thank you very much. Up to this slide, I can stop my lecture. I think something is boring. I don't know.
No, it is very interesting. This is a very fundamental thing that every engineer should know.
Yes, I'm not going in depth also.
Unfortunately, a lot of people fail to explain these concepts.
Yes, correct.
So it is a very good opportunity for students to learn as well. So thank you very much, Dr. Bala.
So thank you very much, sir, for giving me the opportunity.
Yeah.
Thank you very much.
Yeah.
Thank you, sir.
We'll see you on some other time again.
Okay, thank you. Sure,
okay.
sir.
Thank you.